Good morning, everyone. I am MD Tanjid Islam. Today at ICACT 2026, I am presenting our research on machine learning based job recommendation system for Bangladesh. This work is conducted under the supervision of Atikur Rahman from the Department of Mechanical and Aerospace Engineering, Missouri University of Science and Technology, USA. And let me start with the real motivation behind this study. This slide highlights the practical challenges that motivated our research. Bangladesh job market reality. Million plus graduates enter the job market every year. Most job portals rely on keyword based matching. Skill, experience, and job requirements are poorly aligned. Result high application volume, low quality matches. This gap between availability and suitability is the core issue. The Bangladesh job market has unique characteristics. And why Bangladesh is different? Public versus private university gap. Sorry. Different curriculum, exposure, and skill readiness lead to uneven employability. Gender imbalance. Female candidates face structural and cultural barriers despite similar skills. Career stage mismatch. Fresh graduates and experienced professionals are evaluated using the same criteria. This difference make generic job matching systems ineffective. Research gap. Most existing systems fail to address this contextual mismatch. Lack of career stage awareness in existing system. Current job portal treat fresh graduates, mid-level professionals and experienced candidates identically, ignoring difference in expectations and readiness. Absence of age hour matching mechanism. Age related constraints are job suitability are not modeled, often resulting in unrealistic or irrelevant job recommendation. Weak personalization in local job portals. Most platforms rely on static filters and keyword search, failing to capture individual skill profile and user preference. This gap directly motivates our proposed system. Based on this gap, we made the following contributions. Bangladesh specific job candidate datasets constructed from local job posting and graduate skill profiles to reflect real market characteristics, age and career stage our job matching, incorporates candidate age and experience level to improve relevance and feasibility of recommendation, machine learning driven job ranking systematically evaluates decision tree logistic regression nav base for personalized job ranking, empirical analysis multiple feature size investigates the impact of feature dimensionality on recommendation accuracy and system performance. Together, these contributions form a complete recommendation pipeline. System overview. This slide presents the overall architecture of our system. Resume-centric candidate profiling. Candidate resumes are used as primary input to capture educational background, skill sets, and professional experience. Automated information extraction. Relevant attributes such as degree, skill, and work experience are systematically extracted to build structure candidate profiles. Feature representation and analysis. Extracted attributes are transformed into machine-readable features suitable for downstream machine learning models. Learn-based job matching. The system learns compatibility patterns between candidate profile and job requirement to perform effective matching. Personalized job recommendation output. A ranked list of job position is generated, prioritized rule with the highest predicted suitability for each candidate. Each component is designed to capture real candidate job alignment. Dataset summary. To ensure realism, we use real candidate data. 300 real candidate CV collected to reflect diverse educational background, skill, and work experience level. Data source, job portal, and HR records ensure practical relevance beyond synthetic or simulated data. Multi-domain job categories include role across IT, business, engineering, and general services. These datasets reflect actual hiring diversity in Bangladesh. Feature engineering. Effective matching depends heavily on meaningful features. Skill representation encoded to capture relevance between candidate competence and job requirements. Educational qualification degree incorporated to align academic background with role expectation. Normalized age features used as a contextual signal rather than hard filtering criterion. Work experience quantifies professional exposure and career progression. Age is not used as filter but as context. Why age matters? The age distribution reveals a clear concentration of active job seekers between 24 to 28 years. This range primarily represents fresh graduates and early career professionals. Job preference, eligibility, and suitability vary significantly across age groups. Ignoring age context leads to misaligned or impractical job recommendation. Feature engineering, decision tree, rule-based model that capture non-linear decision paths with clear interpretability. Logistic regression, a linear probabilistic model is used for stable and explainable ranking. NAB-based probabilistic classifier based on conditional independence assumption. Training setup. Training train test split. The dataset is divided into 80% for training and 20% for testing to ensure unbiased performance evaluation. Cross-validation. Cross-validation is applied on training set to improve model reliability and reduce overfitting. Evaluation metrics. Performance is assessed using accuracy, precision, recall, and F1 score, which are suitable for classification-based recommendation task. Model ranking. Decision tree consistently ranks highest across different feature sizes. Logistic regression shows competitive performance but slightly degrades with full feature sets. Nap-based performs well with limited features but drops as feature dimensionality increases. Based model performance. Decision tree. Accuracy of 88% is achieved on the held out test sets. A stable weighted F1 score indicates balanced performance across job categories. Consistent performance is observed across different training data sizes. Confusion matrix. This confusion matrix gives deeper insights into prediction quality. Decision tree. The confusion matrix shows strong diagonal dominance indicating correct prediction for most classes. Majority classes achieve high true positive rates. Errors are concentrated in low sample classes reflecting class imbalance in real data. Most errors occur in low sample job categories. Why NAP-base falls short? NAP-base shows limitations in this context. Feature dependency limitation. NAP-base relies on a strong conditional independence assumption which is often violated in resume data where skill, education, and work experience are inherent, inherently correlated. Impact of class imbalance. The model is sensitive to imbalanced class distribution resulting in reduced performance for low-frequency job categories. Re- Real resumes violated independence assumptions. System benefits. Our system provides several practical benefits. Skill-aware matching. Recommendations are driven by candidate skill rather than keyword overlap. Career stage awareness. Job suggestions are aligned with age and experience to ensure realistic opportunity. Market adaptive design. The system reflects local hiring patterns and job market dynamics in Bangladesh. These benefits address both candidate and recruiters. Practical impact. Beyond metrics, this system has real-world impact. Supports fresh graduates. Provide realistic job recommendation aligned with early career skill and expectation. Assist HR screening. Reduce manual effort by filtering and ranking suitable candidate efficiently. Reduce skill job mismatch cost. Improves matching quality, lower recruitment inefficiencies, and turnover risk. It improves efficiency and reduce mismatch cost. Despite promising results, some limitations remain. Class imbalance is one of them. Some job categories contain fewer samples, which affects minority class prediction performance. L- Limited use of complex models is another one. The, the study focuses on interpretable machine learning models. Advanced deep models are not explored. Dataset size constraint. The dataset is moderate in size and may not capture all variation of the national job market. Next, the key takeaway. To conclude, I will summarize the key message. Job recommendation system must evolve from simple keyword matching to context-aware intelligence. Thank you everyone. If you have any question, feel free to ask me.